Okay, this thing is cool. I could just sit here and push these blocks back and forth all day. Maybe I will.
Welcome back to Cloud 42. My name is James, and today we are going down the metrology rabbit hole. You are no doubt aware that I have a surface grinder in the shop now, which means that I, in theory, have the ability to machine parts to an order of magnitude greater precision than I could before. Of course, that means that I also need to step up my metrology game, so I have been trolling eBay, and my friend Andre tipped me off to a used federal Gage amplifier that I picked up, and today we're going to see what showed up and see if we can get it working. And by the way, I am going to use the words precision, accuracy, tolerance, and probably a few others in ways that will make some of you real mad, so do me a favor and vent about that down in the engagement section.
This is the box as it arrived. I already cut the tape off. Looks like it's a motor oil box. Got some foam in here, and okay, this is not packing foam. This is like bed topper foam, like memory foam. It's very nice and soft, but probably not designed for packing. This is packed pretty well. It doesn't look like it impacted the side of the carton at all. It looks like it traveled well. Let's get it out of the box and take a look at what we've got. There is a calibration sticker here on top. Looks like it was last calibrated in October of 2018, due again in January of 2020. So that's a pretty recent calibration. This must have been in use until just recently. Dial looks nice and clean. Let's turn it on. And yeah, no response from the set gain. So if there's a battery in it, the battery is dead. See, it looks like we've got plus or minus 2 thou, plus or minus 4 tenths, and plus or minus 1/10,000th of an inch full scale. That's 5 millionths of an inch per division. Got the zeroing knob over here, and this is a compound knob, so I'm turning the fine adjust, and once it bottoms out, the coarse adjust then follows it, and then you can turn the other direction to back up into it. So the action on that seems pretty okay. Got the adjustment for the needle, but the needle's pretty centered. This is the EAS 1236, so we need to see if we can find a manual for that. But these are the ranges that are on it, so that looks like that's original. It has a gauge head in the back. This is the EHE 1048. It's a little bit rusty, and there's a little bit of cable wear, but the action on the tip seems all right. Should be able to reverse it by just turning this knob, and I'm not entirely sure how these work because the action on the needle seems different when it's in different positions. Like here I can press it up, I can reverse it and press it down and it returns, but in some other positions on the friction clutch it doesn't seem to behave the same way. If you know how these are supposed to work, go ahead and throw that down in the comments. It's got the 8-pin connector, and there is a little bit of corrosion on there. It doesn't look bad. There is some evidence here that maybe a battery leaked at one point. And there's another date here on the bottom, September of 1986, I think. It's kind of hard to read. Now, someone else has been here. There are a couple of extra wires coming out of this connector. It looks like those are just 4mm banana jacks. I have no idea what these are for, but I imagine somebody just used a couple of extra pins in the connector to wire to something inside. We'll have to figure out what that is. All in all, it looks pretty clean. The needle's not frozen, so far so good. Let's see if we can find a manual. I started just by Googling, and the best search results I got were for Federal 230 Gage Amplifier Manual, but all roads lead to this post on Practical Machinist with somebody looking for a manual for a similar gauge amplifier and somebody responding saying, I have one. Go ahead and PM me and I'll send it to you. Okay, just one problem, this user hasn't been seen since December of 2019. So yeah, I think this is going to be a dry hole. There are a couple of other posts like this one with somebody looking for a manual. No reply. My friend Andre was able to come up with a PDF for me, and this is pretty nice. It actually covers all of the 230 series amplifiers. It talks a little bit about the battery installed behind the compartment panel, apparently before they're shipped out. information on how to operate the amplifier, some stuff on the zero adjustment. This is all good stuff, and we will definitely need it. Talks about the battery. Apparently these were furnished with a mercury battery that is no longer available. They've been banned and it's illegal to buy or sell them, so we're not going to be able to find a replacement for that. They did make a power adapter that goes in place of the battery. That would be useful, but I doubt we're going to find one of those at this point either. There is a schematic in the back, but if we zoom in to look at the detail, it's all pixels and no information. This would have been useful at some point, but this has been copied or poorly scanned enough times that this is useless. I reached out to Mar since they acquired Federal and asked about a manual, and Dave hooked me up, emailed me a PDF. Unfortunately, it's exactly the same PDF that I already had that came from Andre. So I put out the word on Instagram and YouTube that I was looking for a manual, and Grumpy Oldman came through. He's Grumpy's Workshop on Instagram. Go check him out. But he had a photocopied version of the manual. He scanned it and sent it to me. This version's a little bit more complete, has information on more of the models, and it has a whole section on the gauge heads, explaining how their little reversing cam is supposed to work, information on the auto-correcting ball tip, which I don't have, and the correction factors if you don't, which I don't, a bunch of info on theory of operation, and most importantly, the schematic in the back is readable. It's not fantastic, but I can read the component values. So if it comes down to trying to troubleshoot or repair the circuitry, I think this will serve that purpose. So thanks, Grumpy. That's exactly what I needed. Let's flip this over and see what's going on inside. I do see something through the little window there, so it looks like there's a battery or something like a battery in there. Take off these 3 standoffs and we should be able to pull off the sheet metal back. There is some evidence of battery leakage here, though it doesn't look really fresh, so I suspect that happened some time ago. Somebody has been in here. The pins on the connector are labeled. That probably has something to do with these extra wires that are added. We'll have to figure out what those are. And there does indeed seem to be a battery. I say seemed to be a battery. There's that same name and date marked on the battery that we saw on the sheet metal. That's cool. A little 2-pin connector with 2 different size pins, but I don't think this is an original mercury battery. It says fused charge 5 volts at 1 amp, fused rechargeable battery pack with a date in June of 1990. And there are several vintages of tape on this thing. So I suspect this was the original EBY 1005 battery box and somebody has opened it and replaced the contents with something else. I'll have to dig into that and see. Let's see if it's actually outputting any voltage. 0.3 of a volt. Nope. Whatever's in here, it's definitely dead. Let's pull the sheet metal back off of here and look at the circuitry. And this looks pretty clean. If there was evidence on the back of a leaking battery, there doesn't appear to be any damage to the board. Yeah, this looks really clean. Got the power wires come down. Those are just soldered directly onto the circuit board here. Got the wires from the connector in the back, and there are our 2 additional wires that don't match the others. And those are going down to what look like the meter posts. Let's check continuity. Yep, that one goes there. And the black one goes to the other post. So those connectors are just attached across the meter. Is that for outputting for some kind of integration into some kind of data acquisition? I don't know. If you have any idea what this is, let me know if you've ever seen that before. Inside looks clean though, so let's turn our attention to this battery and see what's going on. The handwritten date here says June of 1990, and from that vintage, I am going to guess that what we're going to find in here is a nickel cadmium battery pack, maybe 4 C cells that somebody made and stuffed inside the original box from the mercury battery. Under the first layer of tape, it looks like we've got more tape, and there's yet another type of fiber reinforced tape that I hadn't seen on the outside, so I think this has probably been rebuilt more than once. Really don't want to tear this out and break anything. I want to be able to see what it is or what it was. And yeah, this sure does look like they salvaged the connector from the top of the battery and built a battery pack out of some C cells. See if I can get this out of here. I don't want to short anything just in case something in here is still live, but I'm pretty sure everything in here is dead. So there's just another cardboard sleeve, and yay, more tape. There are the nickel strips. I can't imagine using those to build a battery, so those must have come out of the original mercury battery or however it was packaged. I've never seen one, so I don't know what was in them. But most of this tape is really dry and crumbly. There is a fuse there. On the outside it said 1 amp. That looks really heavy. Must be a slow blow fuse. And yeah, there's a bunch of different kinds of tape in here. So yeah, nickel strips looks like. And this connector from the top, I think we can salvage that. And what do we have? Yep, nickel cadmium. Well, it would be right for the vintage. So it really wasn't that crazy of a guess. I do want to salvage this connector. I'd like to reuse it. I'm probably going to do the same thing and build my own new pack, but I have no use for 23-year-old nickel cadmium cells. Even if they're good and even if I charge them, they won't hold a charge, at least not for very long, so it won't sit for, you know, a couple of months on my shelf and then still be usable. So I do want to use the box though, so I'll get all of this old tape peeled off of it, and boy, this is messy. It's just crumbly. The adhesive is all turned to powder. Oh look, we can get a replacement from Duracell International Incorporated. That's good to know. This is a really cool old box. I'm glad we're going to be able to save it. But somebody needs to clean up this mess on the bench before we do anything else. I have no idea the electrical condition this thing is in, so we'll bring it up slowly on a bench power supply. Fortunately, someone has marked plus and minus on these pins. We'll just go ahead and trust that. Connect a couple of alligator clips and set this up on my Rigel DP832 bench power supply. Now, the benefit of using a bench power supply is I can set a current limit. So for channel 1, I will set this to 5.4 volts, which is the voltage of a mercury battery. And I'll set the current limit to 5 milliamps. That way, if there's a short in here or a blown capacitor or some other component, it won't draw enough current to damage anything else. So I'll power this up. It's not switched on yet, but we see 5.4 volts across it. Now we'll switch it on. And it's drawing more than 5 milliamps, so it's pulling the voltage down. So let's go ahead and bump the current limit up 1 milliamp at a time. We're up to about 8 milliamps here, 9 milliamps, and we've reached the full 5.4 volts. We can go ahead and bump the current up a little bit further, bump the limit up to 10 milliamps, 11, 12, 13, 14, 15. We'll go all the way up to 20. It's not drawing anymore. It looks like it's pulling about 9 milliamps, sitting right at 5.4 volts. So it's behaving itself. Switch it into measurement mode here. Actually, plug in a gauge head first. Switch it into measurement mode, and we are seeing needle movement. Let me get this set up on a stand so that we can actually take a measurement here on the bench, or at least control the probe precisely, and see if this is behaving itself. And it seems to be, I'm outside of the range of the adjustment here. Let me move this mechanically down so that we can reach 0. Then with the electrical zeroing knob, there's the fine adjust. Then we'll hit the coarse adjust, bring it up, bring it back down a little bit. That was too far. And yeah, we can bring it to 0. If I press on the table surface or on the block or on the gauge head, we are getting needle movement. That seems plausible. Let's try the other ranges. Here's the middle range. It's still zeroed, and yeah, we're seeing more movement, which is what one would expect. And the highest resolution range, yeah, me just leaning against the bench is affecting this. I mean, it's 5 millionths of an inch per division, so yeah, you would expect it to be pretty delicate. But the zeroing seems to work there as well. Let me put it back in the set gain mode and let's play with different voltages. If I'm going to actually build a battery pack, I need to know what this can handle. We'll bump it up 5.7, 5.8 volts. We're starting to pull 10 milliamps, 5.9, 6 volts, 6.1, 6.2, 6.3. Let's take it all the way up to 6.5. That's the highest voltage I would expect to get out of an alkaline pack. And you can see the gain's a little high, but that can be adjusted. And even up at 6.5 volts, it's only pulling 12 milliamps. So we haven't crossed over some kind of semiconductor breakdown voltage or anything. And the measurement is still pretty much zeroed. So I think we should be able to run this on 6 or 6.5 volts without any trouble. Let's make a battery pack. Let's stop playing with it and go make a battery pack. My plan is to use 4C alkaline batteries, and I've got a little 4C holder here and some new C alkaline batteries. Let's see what we actually get from these fresh. Yeah, 6.4, 6.5 volts. Looks like I was guessing pretty well on the high end. That does seem a little bit high to me. Let's try putting a diode in series. This is a 1N4004 rectifier diode. Should drop about 0.6 of a volt, maybe a little less without any load on it. Yeah, 6.1. That'll come down a little bit more when we get 10 milliamps flowing through it. It should be more like 5.9. I will feel a lot better about that. We've got the connector here from the original mercury battery that we salvaged. Let's take this upstairs to the soldering bench and assemble this into a battery pack. These metal strips have been sitting around for a long time. They're most certainly oxidized. Let's put some flux on here and kind of rub it in good so that we can get a good solder joint. And that appears to be working beautifully. The solder's wetting into the metal. This is lead-free solder, so you know when it's wetting well, you've done everything right. We'll solder the diode right here at the battery connector, and I'll just bend the lead around here, heat it up, wet it in, and that wetted in beautifully. I'll trim this off and connect the red wire from the battery. Tin this first, tin the wire, and then try to melt those together. And again, this is lead-free solder, and man, if you don't have your flux game going, it does not work at all. A little bit of flux though, and that wets in beautifully. And I will put a piece of clear heat shrink on here. Heat shrink so that it won't short out, and clear heat shrink so that somebody who comes along later can tell what I've done. Then we'll hook the negative battery terminal to the other side of the connector. And that is the soldering complete. And we'll tape all of this together with the cardboard spacers. I'm going to use Kapton tape, polyamide. This stuff should last a long time without crumbling and falling apart like the other stuff did. I guess we'll see when I'm dead and gone. Somebody needs to figure out what's going on with this thing. I'll just go ahead and stuff this back into the original box with enough cardboard spacers and just enough tape to hold it together. I don't want the kind of abomination that was on there before. And this should be ready to go into the meter. Use the original connector. I did want to preserve that just because someday I may come across the correct power adapter. And then we'll leave behind some evidence of what's in here so the next person doesn't have to guess. Put the back panel back on, connect up the gauge head, and we should be ready to test. Yeah, it seems to be working. Let's take it over to the surface plate. Let's start out by comparing a couple of these bearings that I ground in a previous video. Let me get this zeroed out on the surface, and that's pretty close. Fine tune it, and then let's slide off of that bearing onto another. Now these were ground in the same setup, so I would expect them to be pretty much the same, though I only ground one side. The other side isn't perfectly smooth, so who knows if these are sitting properly on the surface plate. We're just playing around here at this point. But yeah, that looks pretty okay, and these look to be about the same height. Let's try the next resolution here. So this is 20 millionths per division, 4/10 full scale. And even at that resolution, these look pretty close. If I fish around to different points on the top, we're moving around by, 20, 40 millionths. The bottoms of these are definitely not flat. They were never ground. At least I never ground them. So the fact that these are as close as they are is actually a little bit surprising to me. But the tool seems to be working. I probably shouldn't be handling these too much because as we get into the really, really high resolution readings here, the temperature of the material is going to matter. Let's go up to 5 millionths per division. This is 1/10,000th of an inch full scale deflection. So what is that? 7 or 8 millionths shorter. But everything here matters. I'm just touching this block, and if I move the cable here, it influences the measurement. This is a terrible setup. We're just playing around, but it seems to be working okay. Now, if I fish around to different points on this, the needle's deflecting quite a bit, but just remember, this is 5 millionths of an inch per division. So we're seeing, a fraction of a 10,000th of an inch of difference here. And wow, those are pretty close. These were ground in the same setup right next to each other on the block. Actually, this is number 1 and number 5. These were the furthest apart when I ground them. Let's try some gauge blocks. These differ in height by 1/10,000th of an inch. So in the highest resolution, as I step from block to block, we should be seeing a full scale deviation here. And we are seeing a little bit less than that. That is probably cosine error. I do have the probe a little bit high, and this is not a compensating probe. But in general, to be getting this close, just pushing this thing around on the bench, keeping in mind we're talking about a 1/10,000th of an inch difference between the blocks, I feel pretty good about this. I don't see anything here that makes me think the instrument's not working. I do see things here that make me think my surface plate isn't clean, or I don't have a good controlled setup here, but that's fine. Okay, this thing is cool. I could just sit here and push these blocks back and forth all day. Maybe I will, but I'll cut that part out of the video so you don't have to watch it.
Of course, the problem with being able to measure things precisely is that now I'll be able to tell exactly how bad I am at making things precisely. I've heard humiliation is a good teacher though, so maybe it'll all be for good. In any case, we've now got a cool new tool here in the shop. We just need some projects to put it to use. I have a few things in mind, so feel free to subscribe if that interests you. If you enjoyed this video, give it a thumbs up and maybe consider supporting the channel over on Patreon. And if you're already a patron, thank you. You make all of this possible. Thank you for watching.